All right. Hey, there's a couple of situations that I've come up with here that I was reminded in my own thinking that would be good to work with. They show up a bunch in sapling problems and the problems that we're working with. You're going to be asked to work with. And that has to do with, well, for one of them, for instance, what gave us, what did I have to take the antiderivative, excuse me, what did I have to take the derivative of to get 0? What if I have lowercase f equals 0? What did I take the derivative of to get 0? Yes, I hope that came to mind. If it was some number, a constant, all right? So the cap f could have been like 5. So if you started with 5, you take the derivative of it, what do you get? Y equals 5 is a horizontal line. What's the slope of that line? Well, the derivative of that is equal to 0. So that is the general rule of thumb. And notice this, also you got to remember, if we're doing the cap f's, you got to add the situation here of, you got to remember to always, when it's 0, it's going to just be a constant. So that is where it came from. So the idea of it's going to be a constant. So let's look at another one. If I have f of x, little lowercase f of x equals, is 0, then it could have also been, it could have also come from a million, like I said before. Okay? So the general idea is you've got a general constant there you're working with. So if lowercase f is equal to 0, then cap f must be the constant that we were talking about before. That's where the c comes from, okay? So in general, that's a rule of thumb. Stop and think about it. If c is a million, take the derivative, you get 0. If c is -5, take the derivative, you get 0. All right, that's one thing. Well, another situation that comes up is, what if f of x was equal to 1? All right, what did you take the derivative of to get that? Stop and think. Yeah, the coefficient of an x. So the situation was, the answer was x. And with the cap f, we got to remember the plus c. But the derivative of x is, you have the constant out front, is the answer. That's 1. And then you have to subtract 1 from the exponent. That makes it x to the 0. The x goes away. So in that case, you have the derivative of x plus some constant is equal to 1. All right? So as an example, well, I'll tell you what, let's do another one. What if it was 2? What did I take the derivative of to get 2? Right, it must have been 2x plus some constant. So we've got cap f of x equals 2x plus some constant. All right, so that's the general idea. And if you have, in the general rule of thumb, is that if you have some constant k that's out front, I mean, that you get when you're finding the antiderivative of, well, the cap f then is the coefficient in front of an x plus the constant c that we have to add at the end of the situation. So the general idea is, if I had like 5, so if I had the function 5x plus 7, what's the derivative of that? All right, well, the lowercase cap f of x, which is lowercase f of x, is equal to 5. So the reverse idea is that if you start with a constant, then you attach an x and add some constant. That's the general rule of thumb right there, okay? And remember now, we've also got situations of negative exponents, fractional exponents. Those are extra little challenges. You just got to remember to use the power rule. So for instance, if I have lowercase f of x equals 1 over x to the third, okay? Well, to take just like I'm taking the antiderivative, I've got to put this in a position to bring it upstairs and make it a -3. And now the antiderivative, I use that rule. I raise the power by 1 and divide by that new power. So I end up with cap f of x is raise the power by 1 and divide by that new power. which is x to the negative 2 over negative, I had to add 1 down here, 2. Okay, so plus 1. And then that gives me negative 2 down there. All right, so simplifying that, I end up the 2 is in the denominator, the negative sign is out front, and that x to the negative 2 moves it downstairs. So I end up with a negative out front because what's in front of the 2, 1 over the x squared moves downstairs, and the 2 is already down there. Okay, so I end up with that situation. So you've got to do one step at a time, follow it through, and you work with the signs and that type of thing. Fractional exponents are another thing you got to work with. So we'll practice these a bunch. There's 22 problems in Sapling from this section. A lot of opportunity for practice. Get in there. Some of them you may not have a handle on yet. You'll wait till we talk about it in class a little bit more. We'll practice it some, and any other recordings I might be doing. Okay? So be well, and get in and do the Sapling problems as best you can. Again, there's several, and they'll be definitely due by next test, okay, next Wednesday. So do well. Take care.